Okay, so today we have another antiderivative question, and question 50 says find a function f such that f prime of x is equal to x cubed and the line x plus y is equal to 0 is tangent to the graph of f. Okay, so what does this mean? Well, we want a function f, okay, we don't know what f is, but we want it, such that when we take the first derivative of f, we get x cubed, okay? So we get x cubed when we take the first derivative of this function, okay? And also, this line, x plus y is equal to 0, is a tangent to the graph of f, okay? So these two conditions need to be met, okay? Now notice that I can rewrite this tangent line as y is equal to minus x. Now why would I do that? Well, notice that in front of the x we have the slope of the tangent line. So we can say the slope of the tangent is minus 1. And also notice that when we take the first derivative of a function, we get the equation of the slope of the tangent line at any given point. Okay, once again, we know that the slope of this tangent line is minus 1, and we also have an equation that gives us the slope of the tangent line at any point. So let me set f prime equals minus 1. Now why would I do this? Well, I already know the slope, and I want to know at what x value does that occur, okay? And that's going to be useful. So f prime is x cubed, and that's going to be equal to minus 1. Now taking the cube root of both sides, we get that x is just going to be equal to minus 1. And I'm going to put this in a box because this is important. Okay, this is the x value at which this slope occurs. Okay, so at minus 1, at x equals minus 1, the slope is minus 1. Okay, cool. Now let's get into the antiderivative part. Now I have f prime, and I want to get back to f. So we know that f of x is going to be equal to the antiderivative of f prime of x with respect to x, okay? So once again, taking the derivative I get from f to f prime, and taking the antiderivative I get from f prime back to f, and this is going to be equal to the antiderivative of x cubed with respect to x. Now taking the antiderivative of x cubed, the rules of anti-differentiation tells me to add 1 to the exponent and then divide by that same result that we get, okay? So this is just going to be x to the 4 all over 4, and of course we cannot forget the constant of integration, which means that there is a possibility of there being a constant, and that constant could be anything. Okay, cool. So we know that f of x is equal to this, but I still want to know what the plus c is because we can't just leave it like that, okay? Now let's think about tangent lines. What do we know about tangent lines? Well, we know that the tangent line of a graph touches that graph at one point, and remember, we know at which point it touches the graph, at x equals minus 1, okay? So at this point, this slope is minus 1, and also it touches the graph at that point, okay? So I know that f of minus 1 is going to be equal to, well, how would I write this? Well, I can't really write this in this way, but I'm just going to say it's equal to y of minus 1, just for an understanding. So what this means is that if I substitute in a minus 1 for x on f, then that has to be equal to if I substitute a minus 1 for the tangent line. Okay, so this here is mathematically incorrect. I don't think you can write this in this form, but just for an understanding. So this is going to be minus 1 to the 4 divided by 4 plus c, and then substituting a minus 1 for y, we get minus 1 into minus 1, or you could just say minus into minus 1. Okay, simplifying, this is an even function, so that's just going to be 1 over 4 plus c, and that's going to be equal to 1, and our c is going to be equal to 1 minus 1 over 4. Notice that I can write 1 as 4 over 4, so 4 over 4 minus 1 over 4 is going to give me 3 over 4, and that's going to be the c value. So our final answer for f is going to be x to the 4 divided by 4 plus 3 over 4. Or you could say 1 over 4 x to the 4 plus 3 over 4. And this is the final answer.